This video, we'll do a brief overview of what exactly statistics and machine learning is all about, and we'll discuss the use of prompt engineering to learn statistics and machine learning and implement algorithms in statistics and machine learning. Unless you've been asleep all of 2023, you likely know what prompt engineering is all about. We'll see how prompt engineering can be used to leverage technologies. You'll see that prompt engineering is not just great at generating and debugging code in Python and Java for everyday use cases, but prompt engineering can also be used to learn hard conceptual topics such as descriptive statistics, inferential statistics, hypothesis testing, machine learning algorithms, supervised and unsupervised learning, everything. This particular learning path is focused on hands on implementation, seeking help from generative AI tools such as ChatGPT, Google Bard, and Bing Chat. However, you do need a little bit of a conceptual overview before you can dive in, so that's what we'll cover in the theory videos of this course. First, let's discuss what exactly statistics is all about. So, what is statistics? Statistics is a branch of mathematics and a field of study that involves the collection, analysis, interpretation, presentation, and organization of data. The primary purpose of statistics is to understand and make sense of numerical information that you have, draw conclusions from the data, and use these conclusions to support decision making in various disciplines and real world applications. Statistics has a very practical use case. It's used to make decisions. Statistics is concerned with the use of data in the context of uncertainty and decision making in the face of uncertainty. Statistics involve collection of data from the real world, analyzing and summarizing this data, applying inferential statistics to make inferences and predictions about populations based on sample data. The terms population and sample are fundamental concepts that refer to different sets of data that are used for analysis and inference. It's important to understand the distinction between the two. Now, typically, when you're working with data, you don't have access to the entire population that you're trying to model. The population refers to the entire group or collection of individuals or data points that are the subject of interest. In order to use statistical techniques, in order to understand the characteristics and behavior of the population, you'll typically use sampling methods to sample from the population. A sample is just a subset of the population. It's a smaller, manageable group of individuals or data points that are selected from the larger population. Statistical tools usually operate on a sample of data that you have available. Now, provided the sample has been collected correctly and is a diversified sample and represents the population well, inferences you make about the data using the sample should apply to the population as a whole, should be generalizable. Now, there are different statistical tools that you can employ to understand your data. I'll talk about two broad categories of tools that we'll study in this learning path. The first is descriptive statistics. Descriptive statistics involves the use of methods and techniques used to summarize, describe, and present data in a meaningful and concise manner. It's primarily concerned with organizing and simplifying large data sets to provide a clear overview of the characteristics of the data that you're working with. Descriptive statistics do not involve making inferences or drawing conclusions beyond what you can actually see in the data. Measures of central tendency, measures of dispersion, frequency, distributions, and summary statistics. These are all descriptive statistics that you can use to understand your data. The other category of statistical tools that we'll explore in this learning path will be inferential statistics. These go beyond the description of data and are concerned with making predictions, drawing conclusions, and making inferences about populations based on sample data. This involves using statistical methods to assess the likelihood that observed patterns or differences in a sample are reflective of similar patterns or differences in the entire population. Inferential statistics involve the use of hypothesis testing, confidence intervals, regression analysis, sampling, and probability techniques. We'll see how you can leverage prompt engineering tools to learn and work with descriptive as well as inferential statistics. And then we'll move on to machine learning. Machine learning is a field devoted to understanding and building methods that learn. Machine learning models leverage data to improve their performance on a set of tasks. Machine learning focuses on algorithms and models that enable computer systems to improve their performance on a specific task through learning from data. That is, these models are not explicitly programmed, but the system automatically learns and makes predictions and decisions based on patterns and information that are found in the training data. The primary source of knowledge for a machine learning model is the data that they are trained on. Now, machine learning has algorithms and techniques that can be categorized into two broad categories. These categories do not cover all of the possible machine learning techniques that you could apply on your data, but as a student of machine learning, these are the machine learning models that you're likely to encounter first. Many machine learning algorithms fall under the category of supervised learning. In supervised learning, your model is trained on a labeled data set where each data point is associated with a known target or outcome. The model learns to map the relationship that exists between the input data, the features, and the output, the target. Supervised learning techniques are very powerful and can be used for all kinds of predictions. However, they have one drawback in that they need labeled data. These models have to be trained on a large corpus of labeled data for them to actually make predictions. Another category of machine learning problems that we'll encounter in this learning path will be unsupervised learning techniques. Unsupervised learning techniques do not need labeled data to train the model. When labeled data is not available, unsupervised techniques can learn from the patterns and structures that are present in the data itself. Because these don't use labeled data, they don't try to figure out the mapping or relationship between the data and the labels. There are no labels after all. The goal of unsupervised learning techniques is to discover patterns, clusters, or structures within the data that can be used for predictions or to drive decisions. Now we'll work with both statistical techniques and machine learning models with the help of prompt engineering. Prompt engineering is the field of designing and constructing prompts or input instructions to interact with generative AI models. Prompt engineering is used primarily with natural language processing models to fine tune and tailor their behavior for specific tasks or applications. Generative AI models have been used by many fields and many organizations today. These prompts serve as input or instructions to interact with these AI models, chatbots, virtual assistants, search engines, and other applications. The goal of prompt engineering is to improve the effectiveness and reliability of these systems by crafting prompts that generate the desired responses or actions. Let's talk about where we'll be applying these prompt engineering techniques in this learning path. We'll be working with three different natural language models. We'll work with ChatGPT, the AI chatbot launched in November 2022 that took the world by storm. ChatGPT is an offering by OpenAI and it offers several versions of the GPT series of natural language models. We'll primarily work with the GPT model that OpenAI makes available freely, GPT 3.5. We'll also work with Google Bard, Google's experimental conversational AI chat service. Google Bard uses a different model under the hood, the Pathways Language Model version 2, and you'll find that Google Bard's responses are often very different from ChatGPT's responses in their structure. So it's good to use both of these tools together. And finally, we'll use Microsoft Bing Chat. This has an integration with ChatGPT's GPT series of models. Bing Chat is where you can use the GPT-4 model for absolutely free. The GPT-4 model is available as a paid service on ChatGPT. We'll be building and implementing statistics and machine learning models with the help of prompt engineering. What will we use prompt engineering for? You'll see that these generative AI tools are great at generating code. So you can describe the task that you want to perform and have ChatGPT or Bard generate the code for you. These natural language models can also help you debug code. So you'll type in the code that you have, which has a mistake. Maybe you're not able to track it down, and prompt engineering will help you debug the code. We'll also pass in code and get explanations from the model. Maybe you don't understand what a certain warning is. Maybe you don't understand what a bit of code does. Well, generative AI is here to help. You can also use these tools to improve the performance of your code. Maybe your code is correct, but it runs slowly. Well, generative AI can help you fix that. In this learning path, we'll primarily use Python for coding. However, you can also have these tools help you convert code between languages. So, how will we be leveraging these technologies when we are implementing our statistics and machine learning models? We'll get these tools to write code for us using code generation prompts. We'll also use these tools to understand code using explanation prompts. And finally, we'll have these tools interpret data and results using prompts and image interpretation as well. In summary, as you apply statistics and machine learning, you'll see that we'll leverage ChatGPT, Bard, and Bing Chat to help us manipulate our data and run our models. But along the way, here is an important caveat to keep in mind. Generative AI often makes mistakes. The code produced or the explanations given could be wrong. In all cases, it's always good practice to verify these explanations using other sources.